Okay, so here we are again, AMT 180 aircraft instrumentation. Today we're going to cover temperature instruments and the remainder of some of the engine instruments that we have covered a little bit, but we'll talk a little bit more about them. And then I'll also talk about the midterm that you guys have on Thursday. So if there is anyone live, can you please type in the chat and let me know that you can hear me? I'm going to go ahead and get started. If you do have any questions while I'm lecturing, if you want to review a slide, just type in the chat. Okay. So, like I said, we're going to talk about engine instruments today. We'll go over the fuel quantity. Okay, I see you, Mr. Malone. You say the volume is low. Let me see if I can adjust that. Does that sound any better? Okay, good. So we are going to talk about engine instruments today. We're going to go over the fuel quantity indicator and the tachometer. In the tachometer, we'll talk about tachs for turbine engines and recip engines. We'll talk about mechanical and electric tachs, and then piston engines, turbine engines. Actually, that's a duplicate. And also rotor aircraft, because those have tachometers as well. Mr. Luong says, thank you for learning about OBS. Yeah, you're welcome. It took me a few weeks to understand it. I still don't quite understand it all the way, but I guess we're getting through. Okay, so we will also cover temperature indicating mechanisms. We'll cover piston engine instruments. We'll go over the CHT and some turbine engine instruments, the TIT, turbine inlet temp, TAT, total air temp, and the EGT, exhaust gas temp. And then lastly, we'll cover oil temperature, which is in all engines, whether it's turbine or reciprocating, obviously. And then I do have some slides just discussing what is subjects will be on the midterm and what you guys can expect. So to begin, the fuel quantity gauge is the gallons in tank is considered usable fuel. So the fuel quantity gauge gives us an indication of what usable fuel we have. And we can have a float type fuel quantity gauge. We can also have an electric type fuel quantity gauge. The float type is the simplest form of the fuel quantity gauge. You can also have it contain variable resistors reading which alters the current flowing to the indicator. It's a little brief description on how they work. This is an image out of your AMT handbook, the 8083. Gives you an idea of what the float tank device and indicator look like and a little bit about how they operate. So you have a side view right here. You have your pointer magnet internal to your instrument, and this going to your actual float, which reads that signal. And then you also have this view over here. Again, your float attached mechanically to your crank and pinion gear, which is attached to your dial, and a few other descriptive items there. This is also a diagram relating to the fuel quantity gauge, so you have an idea of where your resistance is coming from. Over here you have your float tank and your tank resistor, so that's how it's being read. the float adjusts, whether the tank, is full or getting lower. The float will adjust, and your tank resistor will read that and send that to your instrument. So we've gone over a lot of this in the fuel flow transmitter mock-up, going through those instruments. And this is a more detailed diagram about this. You can see your fuel quantity gauge here, and it just gives you kind of a block diagram of the system. You have your fuel quantity capacitance type. So this image is an image of a fuel tank transmitter that is used in a capacitance type fuel quantity system. And the capacitance type is what we have on the mock-up that many of you saw. So it will be up to you guys to, if you've done the mock-up, you've probably done a little bit of reading about some of these fuel quantity systems, the different systems, but it will be up to you guys to read about these things in more detail for your test. And tachometers, the tachometer system. Tachs can be remote or direct sensing. They can be either one. They can also be mechanical or electric. This is a good description and image of a tachometer instrument. So you can see some of the components in here. We have the front face of this tachometer. So you can see how it's operated with some of these components. You have a synchronous motor field, flux coupling here, which you'll have to read about how that operates. And this is pointing to your indicator, the whole indicator itself. You have this coil spring in here, and your pointer yoke, which again, those components you will have to read up on how they work. And then this is connected to your battery power, your interconnecting wire harness. And this is connected to your engine accessory gearbox. So that's how it works mechanically. So talking about piston engine tachometers. In a piston engine, the tach measures crankshaft speed. It also monitors engine power and limitations. And sometimes in piston engine tachometers, we also have hour meters that are connected to the tach instrument to monitor operating engine time. So there are some differences between operating engine time and when the engines are ran at full power, when the engines are ran at idle, when the engines are ran on the ground as compared to in the air. So you just need to know that the tachometer on a piston engine is monitoring operating engine time. That's anytime the engines are turned on. It's monitoring that in hours. And the instrument indicator dial is calibrated to measure in RPM, revolutions per minute. So that's revolutions per minute of the crankshaft. And here we have an example of a piston engine tachometer. This also has the hour meter, sometimes called a Hobbs meter. Okay, so this is for a piston engine. You can see that the RPM is measured times 100 revolutions per minute, talking about the crankshaft speed, and you have your hour reading window right there. On the other side here, we have a tachometer for a turbine engine, and turbine engines are measured in percentage of RPM, with 100% RPM being max power for that turbine engine. And those ratings are set by the manufacturers. So, a little bit differences of some readings between piston engines and turbine engines tachometers. So talking about turbine engine tachs is measured in speed of compressor sections. So we are measuring the speed of the compressor, whether it has multiple compressor sections or one area of a compressor section. We're measuring the speed of the compressor section versus the piston engines. We are measuring the speed of the crankshaft. The turbine engine tachometer is an instrument calibrated in percentage of RPM. Like I said on that slide, 100% being max power rating for that specific engine. Rotorcraft tachometers. So helicopters also have tachometers. They will have a couple different tachometers. They'll have one for the engine, and then they'll also have one for the rotor, for the overhead rotor. So this is an example of your overhead rotor tach measured in RPM. You have this is a dual instrument. You have your rotor RPM on the outside and your engine RPM on the inside, okay? So you have these indicators to monitor both of them. So what operates a tachometer? How do they work? We have a few different types, and these are all covered in your AMT handbook, the 8083. We can have a flyweight tach that's operated through flyweights. We can have a drag cup tachometer. These are all mechanisms within your tachometer instrument that describe how the tachometer actually operates mechanically and electrically. We can also have a tachometer generator and tachometer probes. Okay, so these devices, I'm going to tell you that it is good. I would suggest knowing the general operation of how these different tachometer mechanisms work. You don't need to know them specifically in great detail for a couple of reasons, because the FAA doesn't really need you to know the specific details about how the tachometer works, but they do want you to know, from what I've seen on the testing, they do want you to know that these things exist and you know the difference between them, the difference in operating principles, okay? Because when you get out in the real world and you're working on planes and helicopters and jets, you're never going to open a tachometer and see, oh, is there something wrong with the flyweights? That's going to be a job for somebody at an authorized instrumentation shop. So, but you do need to know that these different mechanisms exist and their operating principles, okay? So that's in your reading. That's in the AMT Handbook 8083. Synchronoscopes. Synchronoscopes indicate the degree of synchronicity in two systems. So you'll often see these if you have an aircraft with more than one engine. So if you have two engines, you might see a synchronoscope. And this is a picture of one right here. And accelerometers, they measure acceleration and forces acting on an airframe. And this is a good breakdown of an accelerometer, shows all of the different components. So what you guys will need to know about those two components, the accelerometer and the synchronoscopes, you will just need to know their general operating principles, okay, and what they're used for. I don't expect you guys to memorize all of the spring coils and internal workings. Like I said, it's not really necessary because we are not the ones that will be opening these instruments up. If that ever does happen, that's something that requires more training in a instrumentation back shop setting. So that's the remainder of the engine instruments that I wanted to cover. And now the last thing that we will cover are temperature instruments. So if you remember, throughout our entire lectures, we've gone over classifying instruments, we've gone over mechanisms in pressure instruments, we've gone over pressure instruments and pressure instrument systems. Now we covered all of the engine monitoring systems. We talked about engine performance monitoring systems and engine condition monitoring systems. So last thing we're going to cover before your midterm is going to be temperature instruments. So the engine is rated to withstand certain high temperatures. If these temps are exceeded, the components may fail. So the temperatures of our aircraft and especially our engine operating are very critical. All temperature instruments are remote indicating. Temperature is measured at some point in the engine and displayed on the instrument in the cockpit. So that makes it a remote indicating instrument. We have non-electric temperature indicators, such as vapor pressure thermometers and bimetallic thermometers. Those are considered non-electric. And the electrical reading temperature indicators we have would be a Wheatstone bridge thermometer, we have thermocouples, and ratiometers. These are all of the devices that the FAA wants you to know. I'm going to play this video here because it has, I think this is actually a video that I had in a previous lecture. I'm not sure if I played the whole thing, but about halfway through this video it gives a really good basic understanding of temperature instruments and the mechanisms inside of them, which is the last two slides we've been covering, okay? So this video is going to talk about non-electric temperature indicators such as vapor pressure thermometer and a bimetallic thermometer. Actually, the video doesn't cover bimetallic thermometer. That's something you'll have to read about in your textbook. It is in your 8083. But the video is going to cover Wheatstone bridge and thermocouples. Ratiometers is also in your 8083.
Remember these facts. Fuel and oil pressure gauges have a board-on tube, thermometers. They measure the temperature at sin may be used to indicate manifold pressure. The temperature instruments are all remote indicating thermometers. They measure the temperature at various points on the engine and indicate it on the instrument panel. There are numerous temperature measuring devices, but only 3 are used in these instruments. They are the vapor pressure thermometer, the Wheatstone bridge thermometer, and the thermocouple. Let's take a look at their working principles. The vapor pressure thermometer is a very simple device. It consists of a metal bulb with small diameter tubing running to a board-on tube. The bulb, tubing, and board-on tube are filled with a volatile liquid which is sensitive to changes in temperature. When the fluid is heated, it vaporizes and expands. This causes the board-on tube to straighten and operate a mechanical linkage in the instrument. This linkage moves the pointer on the gauge to reflect a higher reading. As the fluid in the bulb cools, it contracts. The board-on tube curls and a lower temperature is reflected on the gauge. The vapor pressure principle is used in oil temperature gauges. Here we see the bulb which is inserted in the oil system, the tubing and the instrument containing the board-on tube, and its mechanical linkage. Oil temperature gauges may also use another of our 3 devices. The Wheatstone bridge thermometer is an electrical device. It is frequently used in multi-engine aircraft where long lengths of liquid-filled tubing would be impractical. The Wheatstone bridge thermometer has a bulb which is inserted at the point where temperature is to be measured. This bulb, however, is not liquid-filled. It contains a resistor of special wire which increases its resistance to the flow of electricity as its temperature rises. From the resistor, wires run to the thermometer instrument in the cockpit. Located in the instrument are two coils and a resistor, which are not affected by heat. The pointer is attached to a D'Arsonval galvanometer for measuring the flow of electricity. The dial is calibrated in degrees of temperature. As the heat-sensitive resistor rises in temperature, it resists the flow of electricity. The temperature gauge shows the change of resistance as current flows in the galvanometer. The Wheatstone Bridge oil temperature gauge differs very little in appearance from the vapor pressure type, except that it has a cable rather than tubing running from the oil system to the cockpit. A Wheatstone Bridge thermometer is also used for carburetor air temperature gauges. In this case, the resistance bulb is placed in the air intake rather than in the oil system. Our third temperature measuring device, the thermocouple, is based on the following electrical principle. Two wires composed of two different metals are firmly joined together at one end. The opposite ends are connected to a sensitive electrical meter. When heat is applied to the joined ends, electrons will flow through the wires, and their flow will be indicated on the meter. This type of thermometer is used for high-temperature applications, such as the cylinder head temperature gauge. The two dissimilar metals are usually joined in a ring, which replaces the spark plug gasket on the hottest cylinder. In this way, the engine's highest cylinder head temperature is reported in the cockpit. Now, a quick review. The oil temperature gauge can be either a vapor pressure or Wheatstone Bridge thermometer. The carburetor air temperature gauge is a Wheatstone Bridge thermometer. And the cylinder head temperature gauge is a thermocouple. The final engine instrument is the tachometer. This is also an electrical instrument, and the most common type is called a synchronous rotor tachometer. As we shall see, this name pretty well describes its principle of operation. On the aircraft engine's accessory case is mounted a small electric generator. It is called a synchronous generator, and it has a strong permanent magnet as a rotor. In the instrument case is a synchronous motor. The generator and motor are connected by 3 wires. As the engine rotates, it turns the generator's rotor. The turning rotor sets up alternating voltages. These alternating voltages act on the rotor in the motor, causing it to turn at a speed proportionate to the generator's speed. As the engine speed changes, the generator speed changes, and the motor in the tachometer makes a proportionate change. The tachometer's motor and dial pointer are connected by a linkage called a magnetic coupling. As the generator and motor revolve at various speeds, the magnetic coupling deflects the pointer to indicate the exact engine RPM. To review, the synchronous rotor tachometer consists of a generator driven off the accessory drive, a 3-wire cable, and a motor. The motor turns a magnetic drag coupling, which positions the pointer on the calibrated dial. The tachometer is perhaps the most important instrument used for troubleshooting. But all of these instruments give information about the efficiency of an engine. They provide a constant check on conditions inside the power plant. Without pressure, temperature, and RPM instruments, an engine could destroy itself before anyone is aware of its happening. Engine instruments give a warning before serious damage is done.
Working through my private pilot training.
Okay, so that video gives a good description of some of those temperature indicating mechanisms within the instruments. Let's see what... Okay. Okay, can you guys type in the chat? Are you guys still with me? Yesterday in my lecture, when I tried to go to a video, it like cut off the video or cut off the YouTube. Could you guys understand the video in that format, watching it from your computer? If not, I'll attach the video link in the module for anybody that wants to view it. Okay, I see Ken said, yeah, that's good. Okay, well, moving on then. That's some descriptions of the mechanisms within temperature instruments and how they operate. You guys will need to know that for your exam. You will want to know the operating principles of those devices. And we'll talk about more temperature instruments. These are specific to piston engines or reciprocating engines. Oil temperature, well, oil temperature is not specific. That's in every engine, but CHT, cylinder head temperature, is specific to reciprocating engines. So a little bit about CHT. It operates in a similar fashion to EGT, which I think we talked about a tiny bit in one of the previous lectures. We will discuss it more here coming up. The CHT probe measures a voltage proportional to the temperature and sends a signal to the cockpit indicator. The CHT probe is typically installed on the hottest cylinder head, and the hottest cylinder head is determined by the engine manufacturer. I think that was a question in one of your guys' quizzes. Who determines which cylinder is the hottest? That is something that's determined by the engine manufacturer. Okay, so there's more information about your CHT instruments in your textbook, but you definitely want to know what CHT stands for, what it's used for, and that it's a probe type instrument that uses a thermocouple of dissimilar metals to measure a temperature. And turbine engine temperature instruments, we have a few different ones, and this isn't necessarily all of them. Turbine engines can get pretty crazy with the amount of stuff that they measure relating to temperature and pressure. I mean, they have a ton of different probes. They can have one probe, they can have 7 probes, they can have 11 probes, just depends on the manufacturer and how that engine is made. But for this class, we're going to talk about TIT, which is turbine inlet temperature, the TAT, total air temperature, and EGT, exhaust gas temperature. And then lastly, we'll cover oil temperature, which is, again, not specific to just turbines. It's just an engine indicating instrument. Okay, so here we have some examples of turbine inlet temperature, your TIT measuring device. In the middle here we have your probe. your TIT probe. So this is a thermocouple type measuring device. This probe is located at an internal point in the engine near the inlet, as near to the inlet as it can be, measuring total inlet temperature, so the temperature of the air entering the engine. So we have a couple instruments that measure turbine inlet air. We have one right here that's a semi-digital instrument giving you a degree reading in Celsius. Okay. And we also have one that's completely analog up here. And then we have a dual gauge. This is actually telling you your turbine inlet temperature and cylinder head temperature, which is an odd thing to tell you because you either have a turbine engine or you have an engine ran on cylinders. So I'm not sure who uses that gauge. I thought it was interesting to see that as a dual gauge. We have your total air temperature, so static air temperature plus any rise in temperature caused by the high speed movement of the aircraft through the air. That is what total air temperature is. And we have a couple of examples here, a couple of different ones. We have your analog instrument, total air temperature. This one's in Celsius degrees. And then this one is also like a rotating, almost like an hour reader, rotating dial there. And EGT, or exhaust gas temperature. EGT can primarily be used for troubleshooting fuel management. That is a good tool that is used in order for people to troubleshoot their fuel management. It can show whether the combustion chamber is running too hot or too cold, or too lean or too rich, and can be adjusted based on your EGT reading. An EGT probe is a thermocouple type reading, like we talked about in the CHT probe. Both of those are thermocouple type readings. It has the junction of two dissimilar metals, so there's a reading at that junction that is in a voltage reading, and it's converted to a calibrated degree reading. Thermocouple is heated and produces a voltage which is proportional to the temperature at the junction of the two metals. The EGT gauge is a millivolt reader that is calibrated in degrees Celsius or Fahrenheit. Okay, and here's some examples of our EGT. Okay, so you have a dual EGT here with EGT on both sides, so that can be the EGT for your number 1 engine and number 2 engine, or your left and right engine. So that works with each other on one gauge, which is convenient, so you don't need to have two. You also have an EGT and CHT cylinder together in one gauge, so you can read both of those. And you'll notice that a lot of these EGT gauges, like your CHT gauge here, has a range marking, and your EGT gauge does not. This one has a star up here. I would have to look into the manufacturer to necessarily know what that star means. Probably means you don't want to go above this specific degree, because it might be your engine would probably be running too hot. But you can see that a lot of these EGT gauges don't have a range marking, a color-coded range marking. So that's something that needs to be accounted for when you are in the manuals. That's a specific limit or range that would go off of something in the manuals. Some of these other temperature instruments have more color-coded range markings that you can go by just by looking at them at first glance. Okay, so here, this one, your EGT has 25 degrees Fahrenheit division, so it's going up by 25 degrees, so it's divided in 4 here. Okay, so there can be all different types of readings on these instruments. Like this dual gauge here says times by 100, so that's your degrees times by 100. You know, this one also says 25-degree Fahrenheit increments. So you always want to pay attention to your gauge and see how you need to read it correctly. And lastly, we'll go through oil temperature. Above temperature limits, the oil will break down, causing engine parts to move and rub against each other, and engine failure will follow. Oil temp is normally sensed where it enters the engine after it exits the oil cooler. Okay, so our oil temperature and oil pressure are very important for the condition of our engine. Just like our car, we don't ever want it to get too hot. So same with our aircraft engine, we don't want the oil temperature, whether it's piston engine or turbine engine, we don't want the oil temperature to get too hot. And we also don't want it to stay too cold. The engine also expands at a percentage of power, forcing oil to engine bearings. The oil must reach a certain temperature in order for this power percentage to produce the correct amount of power for the aircraft to run according to the manufacturer's specifications. If the oil is too cold, this will fail to happen. Okay, so if our oil is too cold and too thick and too viscous, it's not going to be properly pushed to all of those engine bearings that really need that oil to be warmed up so that it can lubricate that engine so that it can run to the proper specifications. So it's not just that we don't want our oil to get too hot, we need our oil to be warmed up. It can't stay too cold either. Our oil temperature indicator is powered by the aircraft electrical system with an electrical type resistance powered thermo bulb in the oil pump housing. So it talked a little bit about this in the video about using the thermo bulb. That's how all oil temperature is read. The temperature reading is transferred electrically from oil pump indicating thermo bulb to the indicator. So again, a remote sensing instrument. And some examples of our oil temperature gauges. You can see them. There's a lot of different types out there that you'll see. A lot of different types out there that you'll see that they all can vary slightly, but they all operate in the same way. And you'll usually always see, at first glance, these color range markings. That's pretty much standard. You can see some version of those color range markings, which again, I think we went over some of this. Might have been in oil pressure, but we have our max and min, our red lines here. We have our caution areas. You don't want to go below or above, or you kind of should be paying attention to that. And then we have our operating range. That's our nominal range that we really do want to be in. And we also have our dual gauges, our oil temp and oil pressure in one gauge. This one has cylinder temp, oil pressure, and oil temp all in one gauge. So that is like a triple gauge. This one is a little more digital, and you can switch back and forth between PSI and temperature. So all different types. Okay, so that is it for lecture today. That's the remainder of the information that I wanted to cover with you guys. I'll discuss our midterm. So our midterm is this Thursday, the 17th, the day after tomorrow. And I am going to have it posted and available, I don't know, I guess by like 4, because 4 is when we would usually have live lecture. So I'm going to make it available by 4 o'clock on Thursday. I don't know if you guys don't necessarily need to take it before class, but it will be available at any point after that. And it's going to stay open until Sunday the 20th at midnight. So you guys will have all of Thursday, well, the remainder of Thursday, and then the entire weekend to complete the midterm. There is going to be a 2-hour limit on it. Once you open it, it will be a 2-hour limit. That's what you would get here in class. So that's what it's going to be. It's going to be approximately 50 questions, give or take a few. You're going to have about 30 ASA questions regarding the subjects that I'm going to tell you about. So 30 questions coming right from your ASA test guide, okay? And then an additional 20 questions, and those questions are going to be a varied amount of questions. They could be from lecture, could be from your quizzes, they could be from your 8083 textbook. So make sure you guys are reviewing all of that information. Go back and review, you know, the quizzes. I believe they're accessible and they do show you guys the correct answers. So go back and review those. I may pull questions from the quizzes. Make sure to review your lecture slides because there will be questions from the information in lecture, and there will be questions from the 8083. So I hope that you guys are doing some reading because there will be questions word for word from information from the 8083, okay? The whole test is going to be multiple choice or true false, okay? And all of the subjects that we've covered up to this point in lecture will be included in the midterm. Nothing that we've been doing in lab is anything I'm going to be asking you about on the midterm. It may be, you know, similar to stuff we've gone over lecture, but if it's not in the lecture slides, if I didn't say it, if it's not in the 8083 under these subjects that we covered, then I will not ask you it. I'm not going to ask you anything specific to the Piper Cherokee or the UH-1. It's going to be based on information from lecture and your textbook and your ASA. So that being said, these are all the subjects that we have covered in the first half of this semester, of this 8-week semester. We've gone over instrument classification, so all of these are game for the midterm, okay? This is all information that will be on the midterm. Instrument classification, temperature instruments and systems. That would be including oil temperature, EGT, CHT, TIT, TAT, that will include turbine engines versus piston engines, what instruments are included in that, what instruments that we covered are included in rotorcraft, helicopter instruments. So there's actually only one that we covered, so make sure you know that one, which one it is. We went over pressure instruments and systems, including vacuum/manifold pressure system, hydraulic, oil, pneumatic, and fuel. Okay, all of those pressure systems as it relates to the indicating instruments. Also, instrument operating mechanisms, that's everything including board on tube, bellows, thermocouples. Today we talked about thermocouples, Wheatstone bridge. Ratiometers are in your 8083, so all of those instrument operating mechanisms. And if you look in your 8083, it's going to list them all there for you. So any of that information that's in your textbook is possible to be on the test. And then also operational ranges and range markings. We went over that a lot when we talked about pressure instruments and the maintenance of aircraft instruments. You know, I think we went over that in the last lecture, maybe 2 lectures ago, but what we are able to do versus what we're not able to do as a licensed and authorized aircraft maintenance technician, okay? So that's what I mean by aircraft instrument maintenance, okay? So out of the people that are here, if you guys have any questions regarding the midterm or regarding information from today. Oh, one last thing. I am going to post the slides from today's lecture. I'm going to post them today so that you guys have them to study for. Usually I will post them tomorrow after you guys take the lecture quiz, but since you guys have a midterm on Thursday, I will post these slides that we went through today. I will post them today, probably right now after I get off of lecture. So that's it for today. That's it for lecture. That's it for what's going to be on your midterm. So if you guys don't have any questions, that's all for today. If you do have any questions, feel free to type them in the chat. And I will see you guys in lab at 5:30. Okay, thank you.